Okay, so welcome all of you. As I mentioned, we're doing the syllabus, then we'll do parametric equations, then we'll talk about graphing parametric equations, and then we'll have very special examples. We'll look at if you have a function of y in terms of x, how do you make that as a parametric equation? And it turns out that's really easy. That's the good news. Then we'll talk about if you have a line through 2 points. How do you get a parametric equation of a line through 2 points in such a way that it's really easy to understand? So you want to like start at the first point and go 1 second and end and be at the second point. We'll talk about that with lines. Then we'll talk about if you have a circle or an ellipse, how do you find the parametric equations for a circle or an ellipse? Okay. And then we'll look at others. So those could be all kinds of interesting things, and we'll do an example or two. And then we'll talk about going the other way. So if we start out with parametric equations, how do we write it as a y equals x, y equals function of x kind of thing? And we'll talk about that. And then we'll talk about the intersection. So if you have two curves defined parametrically, do they meet? And that's actually harder than it sounds idea-wise, it turns out, because meeting and intersecting as a curve is different than meeting. That sounds weird, but we'll see why. It's kind of cool stuff. So the good news is most people do not find today the hardest day of class. But if you're back in math, you haven't been gone too long for those of you who took it last quarter with Bruce. So it's not too bad. Again, there's no calculus to do, but we will be doing calculus of parametric equations on Wednesday. Just let you know that. So don't think that we're not doing this in calculus. We're doing this for calculus, but we need to introduce this first. Okay, any questions about the agenda before I go over the syllabus? Okay, and again, don't forget to unmute yourself if you have a question you want to say it. And otherwise, pop in the chat box. And just let you know, if you're like embarrassed or something that you don't want to have it on YouTube, the chat box does not go on YouTube. So if you ask a question in the chat box, no, only we know. And if you ask something, then pretty much only we know anyway if you ask it vocally, because it's not one that, a lot of people watch these videos, but it could happen in theory. But I wanted to let you know what the kind of how things work. The reason I post, there's a couple reasons I post on YouTube instead of going to Canvas, by the way. One is that way, if Canvas is down, then YouTube's up. YouTube's always up. I don't think I've ever seen YouTube break. So that's always a good thing. And the other is, if you want to watch it a year from now, you'll be able to watch it a year from now. So if you want to brush up on something because you're an engineer student and you need to try and remember parametric equations, you could do that, because you can go back to the YouTube and go watch it again whenever you feel like it. So whereas if it's in Canvas, you can't watch it once you're done with the class. So those are the reasons that I put it on YouTube. And the other is for students that are not fortunate enough to be able to take a math class, and maybe they want to brush up on something and they haven't ever been my student, but they want to learn math. So I like to do that for the world. So just let you know. Any questions at all? Okay, let's talk about syllabus. Okay, and I know if you had Bruce's class, I teach differently. Just let you know. I'm like a high techie person. So I could do everything on tech, and I do pretty much everything on tech. You're not going to see a whiteboard in the background. I'm going to be watching your questions. I'm going to be listening to you. I'm going to be doing everything on the computer. I'm a very fast typist, and I'm very good at typing mathematically. So we're going to do everything on the computer. If you're wondering, where's the whiteboard? And I'm not going to be writing on a whiteboard. Occasionally, I'll write on the computer whiteboard, just to let you know how things are. Okay, so this is Math 107, Calculus and Analytic Geometry, Part 3. So the Parts 1 and 2 are strong prereqs for this class, especially, and this is the bad news, especially Part 1. So Math 105 is very strong prereq. So you really got to remember derivatives. Okay, we don't do much with advanced integration. Occasionally here and there we'll integrate a few things. But we do a lot of chain rule and product rule and quotient rule. You got to have those down. Okay, those are really, really important. And you have to know everything you ever learned in pre-calc. So that's the other one. So that's an obvious prereq because that you had to have for 105. So just let you know that that's what you need for this. This is, again, enhanced virtual environment. So we are online. I will try. I'm not sure if I can get it done, but there's a small chance I'll be able to, especially for the final exam, do a face-to-face review session. And it would be optional because I can't force you to come to campus. But the reason why, any reason why I feel very comfortable in late June inviting everyone.
Vaccinated by then?
Yeah. And by the way, if you see me in the market or whatever, or outside or something, I will not give you coronavirus. I will not give you COVID because I am vaccinated. And it was awesome. I was one of the first because I got through before LTCC actually because I'm on Boys and Girls Club. So I'm fully vaccinated, and I strongly encourage you to, if you haven't already been vaccinated, to sign up on April 15th because that's the day that they're opening up to all of California. So, and you want to like be really fast on getting that click in on your computer so you can get your appointment, and then you'll be vaccinated sooner. So just let you know, and I feel comfortable with vaccinated people having a review session. I have to convince the rest of the college that that'll be okay too. So just let you know, we'll probably do that, but I can't tell you for sure because I need permission. And we might even have it outside because it's so nice outside anyway, and it's safer, but it's nice outside anyway. But we are in an enhanced virtual environment. We're going to be having webinars Monday, Wednesday, and Friday. So this is a time certain class. So today is like really a different day than every other day. Okay, what are you going to usually be doing right now at 8:42 a.m.? Those of you remember having me in the fall quarter. Yeah, the quiz. So the way the course is going to go, and I felt like that worked pretty well. One is it got you to come, which I'm always trying to do. The other is it gets you to practice written stuff, typed out, which helps instead of just the homework, which is all a little too algorithmic. Okay. And by the way, I could actually criticize it. Do you know why? Because I wrote it. So I could criticize it without like being mean to anyone else. Or I was in charge of the group writing it and I wrote some of it, but I was the head. So just let you know that it's a little algorithmic because it's all computer driven, whereas the quizzes are canvas driven, which means you're gonna be typing a bunch of stuff and I'll be grading it by, and giving you comments. So just let you know. Okay. Oh yeah, I should warn you, by the way, and this is important. Do not schedule your second shot appointment for the day before one of our exams or one of your major exams in any of your classes. If you're anything like me, you will not get out of bed the day after. Okay, so just let you know, I'm not sure if the rest of you are the same, but for the second shot, just let you know, the day of is fine. It's the day after that you're just gone. So I don't recommend scheduling that day of an exam, and that could be my exam or physics exam, whatever you have. So just notes, maybe you'll get lucky and you won't have the, sit in bed all day long because you're so tired, like I was. So just note, those are the things. I think this office phone number, I should probably get rid of it because I'm never in my office. Okay, maybe once a month. You call my office, you're not going to get me. I'm at home. But the good news is I check my email a lot, an unhealthy number of times a day. So Over 100 times a day. I'll be checking my email. So send me an email and I'll definitely be able to, do my best to answer. Okay. All right. So email's great. The online webinars and office hours, as long as we don't get Zoom banged and, some evil person doesn't come in, we're going to keep this as our link. And so far, so good. I've been doing this a year now using the same link. So it's the same link as we had in the fall. I don't know if you realize that. Nothing's different. So it's Wednesday will be the same link we're using now, et cetera, unless some disaster happens, and so hopefully it doesn't. Okay. I have some online lecture notes you can click on, and that will send you some lecture notes. That's not word for word our lecture, by the way. I wrote these a long time ago, but math doesn't change. That's the good news. So they still work. I do have a link to CalcPlot 3D. I don't have Desmos because I figured probably all of you know Desmos now, but CalcPlot 3D is the 3D stuff. We're actually going to go into reality this quarter, right? I don't know if you realize, but we do not live in a two-dimensional world. And everything you've been doing in math has been XY plane. Do you agree? You ever wondered why when we actually don't live in an XY plane? Okay, and the reason is you need to really know a lot more math before you jump into 3D because it gets a little more complex. So, and in terms of programming, graphing is much harder in 3D. But the good news, and I was part of that project, is that it was done. So there's a nice 3D programmer grapher thing, does really well. Okay, the textbook, as you know, if you had me before, which most of you are true, my mission in life the last 3 or 4 years has been make sure you don't have to pay for a book. And you do not pay. This class, though, is kind of a mix of 2 different traditional classes, which means we have to use 2 books, which you don't have to pay for. But that's why there's 2 links. There is the Calc 2 and Calc 3. It's kind of part of being on the quarter system. So some of our class comes from Calc 2, some of our class comes from Calc 3. And I decided to do the Calc 3 first and then do the Calc 2. I'm doing in that order. And I know this sounds weird. You would expect the Calc 2 to be easier, but it's exactly the opposite. The sequence and series is the hardest part of this class, and I put that towards the end. One is you'll be vaccinated. Maybe I'll even be able to help you and on face-to-face. But who knows what life will be. But so I'm procrastinating in a way until the last 4 weeks of class or so, or 5 weeks. Okay. You can print it if you want. That one, of course, you got to pay for your own paper. Any questions about anything on the syllabus so far? Okay, so what we're going to cover, this is meaningless to you probably, Taylor polynomial series, polar coordinates, vectors, differentiation of multivariate functions. So again, we're moving out of the XY plane. Okay, and we're going into higher dimensions. Okay, we will mostly stick with 3 dimensions. By the way, do we live in 3 dimensions? What do you think? How many dimensions do you think we live in? Okay, not practically, actually. So even if you don't know advanced physics, you all know we live in 4 dimensions. This class started at a different time. Time's a dimension. Okay, time is a variable, and it's a very important variable. So we actually live in 4 dimensions. So just let you know that. You may not have thought about that way. I didn't say spatial dimensions. Okay. And then, by the way, if any of you decide to go into very advanced physics, and that's what I did, then it's more like 24, but I'm not going to touch that. It gets weird. So let's stay away from it. So I'll let you read through the student learning outcomes. The prereq, well, if you signed up for this class, you satisfied the prereq, or they won't let you in. I grade on 90, 80, 70, 60, standard. I try to make it standard, easy to understand. you're used to that. Oh, I forgot to change this. I did a copy and paste from last year. So it says the following is subject to change whether we stay online or return back to college. We're not returning back to the college. I really hope that in the fall you'll be back at the college. I won't because I'm on sabbatical, but you'll be back in the fall. You'll see me in the winter, and hopefully we'll be back to face to face. So we are really online only. Okay, but I might try to make an optional review session. And if I can, what I'll do is I'll live stream it on YouTube. So those who can't or don't feel comfortable coming in late June, then you can watch on YouTube is what I'll do. Okay, we have the class itself. There are online assignments, and I want to note, this is really important. It's only like 10% of your whole grade. Okay, it's not something like that. 356, 650, might be a little less, a little more, but it's not a giant part of your grade. There's no reason to cheat on it. We call these, if any of you are interested in teaching and being an education major, we call these formative assessments, which means that you're just learning instead of being tested. So this is where you get good at it. So try to do it without using like Symbol Lab and those kind of things, because you won't be able to on the regular exam. So it's much better to try and do it without the calculator, unless I say these are the kind of things you can use Desmos for graphing. But mostly you're not going to use a calculator. And so that's how those are. Then there's the quizzes, also formative. Okay, not a lot of points in terms of your grade, but what it does is it, encourages you a bit to make sure you actually take them. Then we have 2 exams, regular exams on May 14th and June 16th. We also have the online, we have the final exam. There's also, I don't think I wrote it in here, there's going to be a presentation. So you can have group presentations. I don't think I put it in here, but I will. So we'll talk about that much later. That's towards the end of the class. And those are application presentations. All right, we've already talked about it. We're online. This is always going to work. This link right now of the webinars is not true yet. Anyone know why?
Because this is the first.
Yes, the first. I can't have a link until there's actually a webinar to link to. So, so just a note: don't bookmark this today, or at least don't bookmark it in the next hour or two. When we're done with this webinar, then I'll create a bookmark in YouTube, and then I'll have a playlist. But I can't do that until we actually have a webinar. So just a note. Exams will be used with Proctorio. And I want to remind you, if you do not have a computer that works with Proctorio, then our campus will give you one for free. I should say loan you one for free. You have to give it back at the end of the class, end of the quarter. And that does work. So that's the good news, is that everybody can have a computer. If you've used it with me and it worked, then it should still work. But I'm going to have a practice Proctorio test that you can use. Okay, a little early now to talk about it. Assignments are due by the due date. So the assignments are due a little after class. Don't start your assignment right after class because you won't have time. But what I do is that way, if you work on the assignment, but then there's a problem or two that you get stuck on, you don't know how to do, and you can't figure out, then ask it in class. I'll go over how to do those kind of problems. And then after class, you can go work on it and finish it up. So it's a bad idea to start your assignment after, this class, because you won't do well on the quiz either. Because if you haven't practiced the assignment, good luck on the quiz problems. Okay. In-class quizzes I've talked about, they're going to go from 8:35 to 8:55. And they happen, not today, because we're in for day one, but Wednesday will be your first in-class quiz. Okay. And I don't even know what in class means. They're all online. They're at your home, but they're during class time, I guess I should say. Okay, there will be an application presentation, and you're going to be doing that with partners. And again, it's a little early to talk about it, but we'll go over that a lot in detail in a month or two. Any questions on all the different things that happen in this class? Okay, I have office hours, and my office hours are the same link you're on now. What I will do is my office hours will always be immediately after class, so that if you have more questions after class, you can ask some more questions. I will also have office hours from 6 to 7. I do want to warn you, if you log into the office hour earlier on Tuesday or Thursday, then you're gonna be tortured with statistics because I'll be teaching the statistics class from 3:30 to 6. So just a warning is that if you hear me talking about statistics while you jump into my office hour, that's because I'm finishing up my stats class. So office hours are good, and I of course won't be in a physical office at all. I'll be in my living room. If you have a learning disability, then make sure you contact the Disability Resource Center, and I would do that right away so that you can get accommodations, whatever's needed to accommodate your disability, and it'll happen pretty fast. And they're really good people. So tutoring, I do want to mention about tutoring. For the tutoring, as you get farther and farther into the class, a lot of the tutors will be less helpful. Do you know why? And not the class, the whole sequence of math that you're taking. You know why? Because you're the tutors. Yeah, you may not know it, but you are, the top students at this college, or, there's one level up next year's group. But even like next quarter, you'll be truly the top students. So some will help you, some won't so much. So beware, not all the tutors necessarily know this subject in the math tutoring, but some do. Okay, some really do. If there isn't an option to retry the questions, I'll have to take a look because they're supposed to be. So I can't touch that until after class because I'm busy doing the class right now. So sorry about that. There's supposed to be an option to retry. That might be some weird setting. Okay, the big word on honesty, don't cheat. And just let you know, again, the exams will use Proctorio, so it's watching you. It fixes your screen, all kinds of things like that. So try to practice that kind of setting before you take the exam, especially, so that you actually practice how it's going to be. So this is schedule. And what I decided to do with Eve classes is I take, I put it all in a syllabus. Okay, there's a little bit in the modules. With my fully online class, my regular online classes, everything's in the modules. But for you guys, everything's in the syllabus because we have 3 lectures a week, so there's a lot going on there. So what I did is I have a link to the textbook section, a link to my lecture notes that correspond to that section, a link to the homework due that day, and a link to the in-class quiz. Okay, and I do that throughout. So I kind of find, I'm not sure if you like that better, but I mean, I could put the same thing in the modules, but I think it might be easier in the syllabus. I don't know what y'all think, but then you just go to the syllabus and it's all there. Any questions on that? Okay. Canvas also shows you a to-do list, usually on the right-hand side. It'll say, these are the assignments you need to think about. And that's on the right-hand side as a to-do. Also, Canvas at the bottom of the syllabus has a to-do list right here, has by date. And right now, nothing is darkened out because nothing has been assigned that was already due. But in a few days, Wednesday, April 7th will be darkened out, and you'll jump to the first light one. Any questions at all? Any questions at all about anything from the class? As I mentioned, the good news is we're all used to this now, right? Even though it sucks, maybe you don't think so, but I think it sucks to have to not be able to do things in person, but that's where we are. But at least you should all be familiar, with Zoom. I've been doing Zoom for like a decade. You've been doing Zoom for a year, which feels like a decade probably, right? So hopefully you know how to do all that kind of stuff. Okay, no questions about the syllabus? Okay, if there's no question about the syllabus, I'm going to jump to a question for you, a math question for you. Okay, first thing, what is the most important concept of all of mathematics? At least in my opinion, but you might agree to. What do you think? And one thing is, let's say post-elementary school. So you might think addition, but that's elementary. Slope might be the most important calculus, but there's actually more important in, I think at least, in math. Final theorem calculus is definitely very important in calculus. But how about, no, this isn't even calculus. You learned this before calculus. That's a hint. PEMDAS is important. You actually get that in elementary school, though. Trig, yeah. I don't know if that's definitely, I don't know, I wouldn't. Graphing points. I would go for the graphing points. Algebra is a little too broad. Lines, also important, but parabolas are pretty important too. Here's the thing, it kind of captures the lines and the parabolas. Yeah, function. I think a function is the most important. Okay. Outside of addition is pretty darn important. Or maybe probably the most important is counting. But again, that's elementary school. So post-elementary school, I think function is the most important. You may not agree, but we deal with functions all the time, don't we? So here's a question I have. What is the definition of function? Who remembers? Again, given that it's the most important thing, and you've known it for a long time, you should all know what a function is. Who knows what the definition of a function is? For each x, just one y. Okay, so that is a simplistic definition of a function. And that's a warning. Okay, x and y, again, that's simplistic. And because today we're not going to use x and y, just a warning. Yeah, domain and range. Okay, so functions are much bigger, much more general than just put a number in, get a number out. It turns out. So let me write down the definition of function, and it's not just the two words domain and range, but it does have those two words in it, and that is, it is a map that sends every element from a domain set to a unique element of a range set. Any questions on that? Okay, that you learned a long time ago, and you've been using it. Okay, any questions on that? Okay, so now I got a tough little question. Might not be tough, but let's see how you are. Think about a circle, which you may not remember, but that was the first mathematical shape that you learned as a person. Okay, for every child I've ever seen, that's the first one they learn, and it's really cute when they say circle. Circle. I was actually with my grandnephew, who's almost 2 years old, and he can say the word circle. He does not know parabola. He does not know line, but he knows circle. Okay, so circle they all know. Can that be described by a function? What do you think? See what you all think. Okay, so x squared plus y squared equals r squared. Is that a function? So we got some yeses, we got some not supposed to be's. Okay, the answer used to be no. And I'm going to say used to as in your education. Okay, so when you learned about circles in algebra, the more advanced circles, and you learned about testing to decide whether something was the graph of a function, what did you learn visually? Starts with a V. Yeah, vertical line test. So based on the vertical line test, is a circle the graph of a function? What do you think? Yeah, definitely not. Okay. The vertical line test, circles fail miserably, right? That's usually the first example you get when you learn the vertical line test, right? On the other hand, the circle is a graph of a function. But unfortunately, or fortunately, it's a function that you haven't learned this kind of function yet. Okay, it's not the graph of a function of y in terms of x. So this is why we need to make sure that when we look at the definition of a function, we don't want to say given x, we get a y. Because if we say that, then the circle is not the graph of a function. Instead, what we want to do is we want to define what's called parametric equations. So let's do that. Now that you all know what a function is, I can use the word function and say that a parametric equation is a function. And let me remind you on this notation, when you have something and then an arrow and then something else, the left side of that something is the domain, and the right side is the range. So a parametric equation is a function that takes R1 and sends it to Rn. Okay, in this section, Rn will be 2. So what that means is that you give the function a number, and the function is going to spit out 2 numbers. Because that's what R2 means. It means a list of 2 numbers, an ordered list. Any questions on this idea? Okay, so what do you think the most important application for R1 will be? Okay, and I don't expect you to immediately know, but you might just be able to guess it in the real world. So not some math terminology, something that you've known since you were a baby. You don't know? Not seeing everyone type it in the box. Okay, so now let's go back to thinking about playing on a big circle. And you're gonna like start in the circle and have a good time and run around the circle, right? Well, it turns out what you can, if you want to actually follow the running instead of just seeing the circle, but actually observe that it's being run around, how fast they're going and stuff like that, then time is the domain. So if you wait 2 seconds, then you're going to be a little farther along the circle. Do you see that? If you wait 30 seconds, you'll be at a different point on the circle. So for every point in time, you'll be on a different place on the circle. Any questions on that? Okay, now let's see if it really is a function. Remember, functions have to be unique. So we know that it sends a circle idea, but for every time you're running around, you want to see where you are during that time, at that time. Well, is it truly a function? Is it unique? What do you think? Do you get a unique point for every time? Yes, yes. You can't be in 2 places at once, no matter how hard you try. Okay? So if you think about the idea of running around a circle, then that is a function where the domain is time and the range is the xy plane. Any questions on this idea? So I want to give you the idea before I type out a bunch of algebra, because I know you've all run around a circle before, I hope, right? Okay. So typically you want to let time, not always, typically you want to let time be the domain variable, and you're going to let position, okay, sometimes some other things, but most often position be the range variable, okay? And that variable will now be a list of numbers instead of a single number, the range, okay? And you can imagine, even though we're not going to do it today, it's very easy to generalize this and think about, instead of running around a circle, maybe you're running around a mountain where you're going up and down and left and right and forward and back, 3 dimensions. And there's no problem thinking about it. We've all done that, right? Okay. Okay. Or if you're in a plane, then you're definitely in 3 dimensions. You can go out, you can definitely change elevation. You can go north, south, east, or west. So at any time, you're going to be at a single position in 3D. Any questions on the idea? Digital audio domain is time, range is amplitude. Okay. Actually, Rigney, it's more than that. Range is amplitude and frequency. Because the amplitude will tell you how loud you're hearing it, but the frequency will tell you whether it's a high pitch or a low pitch, right?
Well, the frequency in digital audio is encoded into patterns of amplitude. So
Okay, well
frequency
then
is
you have
more of like
volume.
an analysis.
Then you have volume. If you're going to encode it in amplitude, which is not usually what they do, not in physics at least, usually you encode it in frequency as the tone, and you encode amplitude as the volume for the full processor. Okay, and it can get more complicated than that, but I think I'm not going to get into the more complication. It was actually the very first study I was involved in as a student was on that. Was they saw who could do better, mathematicians or singers, on making music on the computer. And we won because I suck at singing. But I was really good at creating beautiful music using amplitude and frequency. So I've actually done it. Okay. And definitely in astronomy, same idea. Okay. Then it's not quite sound, it's light. And that has frequencies also. So there, again, there's lots. The other thing, sometimes you'll see as a domain, not always, but sometimes, is angle. Sometimes you'll see the angle being the domain variable, and then there'll be an output depending on what the angle is. Okay, that'll happen with parametric sometimes too. Any questions on this definition before we do a lot of examples? Okay, again, there's not much to like write down in theory. It's really about practicing. Okay, so now let's do some examples. All right, so the question is, graph the parametric equations, x of t, let me make that a little bigger. There we go. X of t equals 2 minus t squared, and y of t equals 2 plus t squared. Okay, you look at that, it kind of feels like a parabola, doesn't it? Right? Okay, do you think this is going to be parabolic when you graph it? So the key is, right now, if you haven't done any parametric equations, you probably have no idea. It just might feel like it. Turns out, no. Nothing. It's not a parabola at all. Any questions on at least looking at this and seeing that these are parametric equations? So when you write parametric equations, you must list the x as a function of t and the y as a function of t. So it looks different. And by the way, for 3D, even though we're not doing it today, what do you think comes after that? What do you have to add on? Yeah, you have to do z of t. Okay, and it's no big deal. Graphing is a big deal. Graphing in 3D by hand takes like serious artistic ability. You're not going to see me do it well. Just let you know that. But graphing with computers are good. So I'm going to look at this and let's use Desmos. And so it's 2 minus t squared, 2 plus t squared. So here's Desmos. So first thing is, my guess is you've never done parametric equations in Desmos. Am I right? Maybe you have, but I doubt it. Okay. But the good news is, so the bad news is you haven't done it. The good news is Desmos does it. So you just have to know how to do it. So what you do is you put a parenthesis, and then you put the x function, which is 2, was it plus first or minus first? Now I got to remember. That guy. 2 minus first. So we have 2 minus t squared. And then you put a comma. And then you put the y coordinate. So it's coordinates, like x and y coordinates, but each coordinate is a function. So I think they've done a pretty good job. I think that isn't too evil. So now I'm going to put in 2 plus 2t. Sorry, 2 plus t squared. Does that look like a parabola? Doesn't look like a parabola to me. Maybe we've just zoomed in too much. What do you think? Okay, so maybe we should let t not go from 0 to 1. Let's let it be bigger. What do you think? So let's go from, how about negative 10 to 10? Did that make it look like a parabola? No, what does this look like? Not a trick question. Yeah, actually it is a trick question. It doesn't look like a line. It looks like a ray. Do you agree? Notice that we never got past this point right here. Does that make sense? So it's actually, this is not a line, it's a ray. Because x will never get big. The biggest x could ever be is 2. And that you could see in this equation. We have 2 minus t squared. No matter what t is, you're subtracting from 2, and you're going to get smaller than 2 unless t is 0, and then you stay at 2. You'll never get to 3. Any questions on that? And similarly, but backwards with y will never get less than 2. Because 2 plus t squared can never be less than 2. So notice that there's a domain thing. Any questions? Any questions on at least looking at this? Okay, so I wanted to give you one that I was guessing you probably wouldn't guess what it was. And this is array. But here's the thing, and this is something you got to be careful of. Looking at what Desmos gave is not enough, because parametric equations give more information than the graph. If I showed you this graph, there is no way that you could come up with these parametric equations and know that it's the answer. Okay, because 2 minus t to the 4th and 2 plus t to the 4th will look exactly the same. And what we're missing with this graph is how the particle is moving. And that is really important. Okay, in engineering, that's a big deal, because if you speed up and slow down as you move along the curve, that matters. Okay, if imagine driving. If I told you that this was the path of your car as you drove, and then could I ask you, did you get a speeding ticket? Could you answer if all you had is looking at this and there was a cop following you the whole way? Could you tell me whether you might have gotten a speeding ticket? No, you have no idea how fast you're going. All you have is the path you're going on. Do you see how that works? So parametric equations, actually, the equation itself turns out that for any point, it'll tell you how fast you're going and in what direction. Next time we'll get into the how fast. Okay, but you can imagine if we're starting at 0 and then letting t increase, then x goes down and y goes up. Does that make sense? So that means we're going to start here, and then we're going to move up left. And we're going to speed up as we move. Because notice from 0 to 1, the y coordinate, for example, has moved up 1, went from 2 to 3. But from 1 to 2, it moves from 3 to 6. It went a lot faster. So parametric equations give deeper information than just the graph. Okay, you can actually visualize how the particle is moving, which is very important in many applications. Okay, not just whether you got a speeding ticket, by the way, but there's lots and lots of applications. Any questions on that? Okay, so this is an example, and maybe I'm going to have you try one. Give me an example. First person who puts something in the box, I'll pop it in Desmos, and we'll take a look. So give me your x and give me your y, functions of t. Somebody's got to try. Can't go wrong, by the way, as long as you use the letter T. And give me an X and a Y. Okay, good. So that's going to be 5t plus t squared. And again, you always put parentheses around it for Desmos. So 5t plus t squared, comma, t minus 10. Okay, and let's change the range of t to how about -10 to 10. And I'm not seeing it. Just a minute. Let's get rid of this one. Did I type something in wrong? It looked good. I got to go below. I think. There it is. Got it. Found it. Okay. Okay. And because I knew what it was going to look like before. I just had it positioned wrong. Big numbers got big. So you'll notice that this is a parabola, but it's a sideways parabola. Okay. By the way, if you have a function that you're used to, do you think you could always write it in parametric form? What do you think? So do you think it's always possible to take a function that, like y equals sine of x plus x or something? I don't know. And write it in parametric form. Do you think you can? Yes or no? What do you think? What's your guess? Or are there some functions that don't work? Okay, no is a good guess, but it turns out the answer is yes. You don't know how? Okay, so the good news is it's fine that you don't know how. But in 5 minutes, it won't be fine if you don't know how, because that's what we're doing next. So now what we're going to do is we're going to look at, say, well, if you have something you're used to, how do you make it parametric form? Okay, so I'm going to start out with when you have a function. Functions turn out to be the easiest. So here's the steps. Steps for converting coordinates, functions of x to parametric form. And it's really easy. 1, let x equal t. Do you agree that's easy? That'll always work. 2, substitute t for x. Substitute t for x in the equation. And let that be y. That's it. So it's as easy as it sounds. So let's suppose we have f of x equals x minus cosine x. Then what is x of t? Hint is very easy. So what's x of t? Not quite. Look at step 1. Hint is it's very easy. That's the hint. Super easy. T. That's step 1. Is that clear? We let x equal t. That's it. And then let y equal. And what do we write? Now, Alexi, you can tell me because you've already typed it, except lowercase, of course. Okay, so we let y, where we see an x, we write a t. T minus cosine of t. That's it. Was that like super easy? One of the easiest things you've ever had to see in math? Okay, and that always works. Okay, and that will make it so that'll turn your regular function into a parametric set of equations. Any questions on that? Piece of cake? Okay, do you think it can get harder with other things that are not functions? Absolutely. Absolutely. It can get a lot harder because this is the easiest possible. So let's go to the next one. Next one's not too bad. So let's do, I thought I had one. Oh, I didn't have this one. Okay, let me write one. So find the parametric equations for the line through the points 2, 5 and -3, 4. Okay, so this also is going to have step by step. One thing you could do is you can find the equation of a line using slope and y-intercept, solve for y, get y equals some, mx plus b, and then go and do step 1 and 2. All right, and that'll work. It turns out there's 2 issues with it. One is it's a pain in the butt. It's a lot of steps, no fun. But the bigger issue is you end up with a parametric equation of the line where the starting point is not very interesting and neither is the ending point. So what we want is we want to say when t is 0, we're at the first point at 2, 5. And when t is 1, we're at -3, 4. And that is a lot better for describing this. Don't you agree? Than just when t is 0, you're at some random point on this line. Okay, so let me give you the steps for finding parametric equations of a line through 2 points such that at t equals 0, it's at the first point, and at t equals 1, it is at the second point. Okay, so step 1. Okay, so the key on this is when you think of lines, this you learned in beginning algebra, what 2 important numbers do you think of when you think of equation of a line? In words, I'm looking for words. Yeah, slope and y-intercept. Okay, but I want to specify y-intercept. The word intercept is actually not enough. Okay, and by the way, is there just a y-intercept and an x-intercept? Or are there other intercepts? And here's the key. You've never seen another intercept, but there is. There's a t-intercept. You've probably never thought of it before, right? And that is at time 0, where are you? Do you see that? So we're going to be looking at a slope and a t-intercept. So step 1, let's do the slope first. Find the slope. But the slope is not going to be a number. Again, you're going to have to broaden your thinking because you've always been thinking of the slope as a number and a y-intercept as a number. Neither of them are going to be numbers. The slope is going to be a vector. Find the slope by subtracting the second point from the first as vectors. If you haven't heard what a vector is, that's okay. I'm not going to get into it today, but we're going to spend like a whole chapter on vectors. And then if you take fourth quarter calculus, the Math 202 class, that's pretty much all you do. Vectors are really important. If you've had physics, are you guys in physics? Has Kathy talked about vectors? Okay, good, good. So those of you who had physics, you know what I'm talking about. Those of you who haven't, just live with it. And trust me, they're important. So we want to think of these points as vectors. Okay, and step 2 is the first point, or maybe note, the first point is the y-intercept, or the t-intercept. Step 3, so when you think about an equation of a line, you're used to y equals mx plus b. Now it's going to be your vector equals m times a vector. So m times t plus your b as a vector. So when I do the example, you'll see it. So write it as a form. So it's not going to be y. Y is a bad letter for this. It's going to be xy. And if you haven't seen this before, live with it, because we'll be doing this much later in the class. So I want to write the kind of right way of doing it. So it's going to be x comma y equals m t plus b. So the nice thing is it kind of looks like the equation of a line. You remember it, right? Right? M is the first letter of slope, so it works perfect, right? Right? It is in French. Okay, so what we're going to do now is let's do this example. So what we can say is step 1, our slope is going to be, let's write it out, and I'm going to write it with pointies just because that's more formal. So we're going to subtract the, it should be, sorry, I made a mistake. It's the first from the second. The grammar thing. From the second. Or the second minus the first is another way of saying the same thing. So we're going to go -3, 4 minus 2, 5. And again, if you haven't seen vectors before, then the way you subtract is component-wise. So -3 minus 2 is -5. And 4 minus 5 is -1. And that's, -1. And that's going to be the slope idea. Any questions on this? Okay. But it's a vector slope. It's a little different. Step 2. Step 2 is very easy. Step 2, I'm going to write b equals. Maybe I'll write m equals here. So b equals 2, 5. Any questions on that so far? Okay, step 3. Step 3, I put it together. So we're going to have xy is equal to m which is -5, 1, -1, t.
You're running off the screen there.
Thanks. Yeah. Let me know, by the way, because I could see it. For some reason, it shows me that you could see that low, but you can't. And I'm not quite sure why Zoom does that, but Zoom does that. So sorry about that. So always tell me if I'm running off the screen. Okay, so xy is -5, -1 times t plus b, and b was 2, 5. Okay, now technically this is correct. It's not the way you're going to see it in the book because they don't do vectors yet. So let's do it the way you see it in the book. And when I say do it, that means just kind of clean it up a little. And that's just write it out. So what we can say is that x of t, let's write it in pretty. X of t is -5t plus 2. And y of t is -t plus 5. By the way, let's suppose that this was an exam and you really cared about your grade and you had extra time. What should you do now if this were a question I asked you? Okay, graph it. Okay, and that's definitely one thing, but there's a much easier way of checking your work, and that's plug in 0. And what do you get? If t is 0, what do you get?
First point.
2, 5.
2, 5, and that's what you want, isn't it? Because we're supposed to start when t is 0, you should be at the first point. Then plug in 1, what do you get?
-3, 4.
Right, and that's good because that's the second point. So it's actually really easy to check your work. Plug in 0, you should have the first point. Plug in 1, you should have the second point. Does that make sense? If not, you screwed up. Okay, and by the way, there shouldn't be any funky things like if you had a cosine of t somewhere, you should worry a lot. So everything should look linear, no quadratics or any weird stuff, no e to the t's. Okay, but I do want to warn you that lines don't have to look linear. And that's why, remember that first example, that was a ray. Okay, if I use t cubed instead of t squared, you'd end up with a line, by the way. So beware of seeing parametric equations and saying that can't be a line because it doesn't feel linear. Feel doesn't work. So that's just a big warning. But again, what this particular process does is it does the easiest way of finding the equation of the line such that you're giving that information where you're starting at the first point and when t is 1, you're at the second point. Any questions at all on this example? Okay, let's do the next example. Okay, so we want to find parametric equations of the circle of radius 2 centered at -1, 3. And that one's a little harder to come up with. It's actually not hard to do if you know how to do it, though. So the key is, who remembers the equation? Forget centered at, how about centered at 0, at 0, 0? Who remembers the equation of a circle radius 2? Centered at the origin. I'll worry about the pushing. Yeah, x squared plus y squared is 4. Okay, hopefully you all remember that. Okay, now comes the interesting thing. Now we want to think about, can we turn that x squared plus y squared equals 4 into an equation that kind of relates to it or correlated to it, but only has one variable? And the key here is what you learned after algebra when you talked about circles. What's another way of dealing with circles that you don't have to deal with algebra? How did you think about circles post-algebra? Who remembers? Their area. Okay, the area is a number from a circle, but in terms of you spend a lot of time, you spend a whole class in it. That's a hint. Just doing this. Unit circle, and what class was it? Yeah, trig. Okay, so the key here is to use trig. Okay, and you could use t or theta. I'm going to use t because I'm lazy. Typing theta is a pain in the butt. Typing t is really easy. Just let you know that. So I'm going to use t. So the first thing is, if we let x equal, what did you let x equal to in trig? Yeah, cosine. And you could use theta. Trust me, if you're going to have to type it, use t. And on a test, you got to type, sorry. So t's easier. Okay, x equal cosine t. And y equal? Sine of t. Okay, the problem with that is x squared plus y squared is not 4. So if I want x squared plus y squared to be 4, how can I adjust this slightly? It's an easy adjustment. Because x squared plus y squared is 1, right? Cosine squared plus sine squared is 1. I want it to be 4. Any thoughts? The hint is it's very easy. You're on the right track. Dividing by 4, x squared plus y squared will be 1/16. If you actually did it. So you want to divide by 4. You're close, though. Any thoughts? Okay, if you multiply by 4, then x squared plus y squared will be 16. So you're even closer with multiply by 4, but a little bit slightly different. Yeah, 2. So if I let x equal 2 cosine t and y equals 2 sine t, then x squared plus y squared is 4. Any questions on that? Isn't that easy so far? Okay, now the problem is I'm not centered at 1, 3. So the key on this is, and it's very easy, I need to get x to be -1, right? I want it centered at -1, 3. So I want x to be -1. Okay, so what can I do? Any thoughts? Because now let me remind you of the equation. Okay. Yeah, +1 minus 3. So let me remind you the equation where that comes from. So I need a fraction out of this. There we go. It was x. Actually, let's do x or 2 times x plus 1 squared plus 2. Actually, let's just drop the 2. Plus y minus 3 squared. Oops. there. Y minus 3 squared was equal to 4, right? So what I need to do is I need to do shifting. Okay. So instead of x, I want to make sure that if I have, and let's just write it this way, we want x plus 1 to be 2 cosine t, and y minus 3 to be 2 sine t. Okay, any questions on that? And that way, when x is 1 and y is 3, we have our center. We get that 0, 0. So now what I can do is I can take this guy and solve for x and y. So I subtract 1. And I add 3. Nothing's hard, but sometimes a little tricky. You know, when you look at the algebra I did, it's very simple. But you have to know what to do. So what I did basically is if we have a different center, I add the center. I added -1 and I added 3. And that shifts the curve parametrically. So it's actually pretty easy. Any questions on that? Any questions? Okay, let's do another example. Find the parametric equations for the ellipse. X squared over 4 minus y squared, y minus 3 squared over 9 equals 1. How is this different than what we just did? And the good news is it's not very different.
Is it because it involves multiplying now because we have numbers in denominators?
Multiplying in specifically multiplying by different numbers for the sine, for the cosine and the sine. Do you see for the x and the y? So it's actually quite easy. We just let x of t equal 2 cosine of t. And y of t equal, it's not going to be 2 sine t, what it's going to be. Yeah, 3. And it'll be sine of t. And then again, the center now is 3, right? Y is 3, so plus 3. And you could double check and you can look at x squared over 4 plus y minus 3 squared over 9 and realize that if we take y and subtract 3, that gives you 3 sine t. So 2 cosine t quantity squared is 4 cosine squared. Divided by 4 is just cosine squared. And then 3 sine of t quantity squared is 9 sine squared. Cancel the 9s, you get sine squared, and cosine squared plus sine squared is 1. And it works. Just a note, I don't think I'm going to do the example, but if you had a hyperbola instead of an ellipse, how would it change? So if this were a minus instead of a plus, right there, how would that change? What would we do? Any guess? And the hint is a hyperbola. You got to have that word. Any ideas?
Changes to caution cinch.
Yeah, use hyperbolic trig. and it all works. So you could use cosh and sinh, and you'll get a hyperbola instead of an ellipse. And that's why they call it hyperbolic trig. I don't know if you realize that. They call it hyperbolic trig because cosh and sinh are the natural parametric functions for hyperbola. Any questions on that idea? It's kind of pretty, isn't it? Here's another question. I'm going to copy and paste. So if we do this, then we'll end up going counterclockwise. What if we want to go clockwise? Because remember, parametric equations are more than just the graph. It's how you're moving. So if we wanted to move clockwise around the ellipse instead of counterclockwise, what would we do? The hint is it's very simple. Any thoughts?
Would it just be negative on both terms?
Not putting negative on both of these guys, but negative on the t's. So then you're changing the direction of time. Does that make sense? And that'll go clockwise instead of counterclockwise. And that will work. And if you wanted, you don't have to, but you could realize that the y will be have the negative, but the x won't. And that has to do with trig identities. Sine of negative t is negative sine of t, and cosine of negative t is cosine of t. But you don't need to do that. In fact, I think it's better not to, because this actually like emphasizes the fact that you're going in the other direction. So if you ever want to go in the other direction, then all you do is you put negatives in front of, you replace t for negative t everywhere. Okay, what if you want to go twice as fast? Also very easy. Any thoughts? Yep, everywhere you see a t, put a 2t. T over 2 will be half as fast. Because if t was 1, guess what? Now you've only moved a half of an angle. Does that make sense of a radian? So you definitely want to multiply by t. I won't type that out, but it's pretty easy. Any questions on this example? Okay. All right, now comes a harder one. Now, suppose you're watching a car move down the road, okay? And you notice a butterfly hanging out on the tire, okay? Clamped on as hard as it can so it doesn't fall off, okay? And the tire is of radius 2. Okay, I'll let you decide what the units are. I don't care. Okay, if the car is moving at 10 miles an hour, find the parametric equations for the path of the butterfly. Okay, so imagine it's going to move, right? Is the butterfly going to move in a straight path? As it's hanging on to the outside of the tire. Not the bottom of the top, because it'll get killed, but the outside top. Okay, there's going to be some cosines and sines, but it's not just sine and cosine. So the key on this one, it's a little similar to what we did before, is before we looked at the circle or ellipse, and we did it at the origin, and then we moved it away from the origin. So there's really two things going on here. One is the car is, if you're a driver in the car, then it feels like you're just moving along a line at a constant speed, right? So we do that piece kind of focused on the driver, or let's say the center of the wheel. But then also the wheel spinning. Do you see the two things going on? And what we can do is we combine those two pieces. Any questions on that? So let's do the wheel first. So first, just focus on the around the wheel. Okay. Oh, I guess I do need to make it, oh, what a pain. You know what? I hope you don't mind. I can make it kilometers. I hate our system. You'll understand why in a moment. Okay. And let's say it's radius to make it a really big tire, meters, just to make it easier. Okay, so we have radius to 2 meters, right? So let's first just go and just ignorantly write down x of t and y of t, kind of not worrying about how fast you're going, but just going around in a circle and not worrying about that you're moving along the road. So let's do that. So x of t is equal to, it's going to be the radius times the cosine of t so far. And we'll adjust. What is the radius? Yeah, 2. 2 cosine of t. Okay, except it's not going to be t anymore. So now we got to think some more, because it's not going to be 1 revolution every second. Okay. How are you going to get the revolutions? We're going to go t times, and now we got to go for adjusting by revolutions. So we know that 1 car circumference is how much? What's the circumference of the car, of the tire? 1 tire circumference, sorry, not car. What's the circumference of the tire? Had it been March 14th, last month. Yeah, pi, there's a little more to it though. Pi's part of it for sure. 2 pi r, remember? Remember the circumference is 2 pi r. Any questions on that? So the circumference is 2 pi r. R is 2. So the circumference, let's write this down, is 4 pi. 2 pi r and r is 2. Let me get that pi. Any questions on that? Okay, but we're going 10 kilometers per hour. Okay. Any questions on that so far? So if you're going 10 kilometers per hour, then in 1 hour, you're going 10,000 meters, right? Any questions on that? So in 1 hour, we're going 10,000 meters. And I think I'll use hours as our variable, as our unit. So what do we do? So you're going to go 10,000 divided by 4 pi. Guess I need a parenthesis. There it is. I always have trouble finding pi. T. It's 10 kilometers per hour. So in 1 hour, you go 10 kilometers. And 10 kilometers is 10,000 meters. because a kilometer is 1,000 meters. Which is why I dropped miles, because miles and feet are not pretty, or 4,280 is too messy. I like kilometers. Okay, and then we have y of t. Same thing, except now we're going to have, instead of cosine, sine. So I'm going to do a copy and paste, put in sine. Any questions so far? I decided to just do it in hours. Yeah, if you want seconds, you could do that, but then you need to make another adjustment, and I got lazy. So I'm doing per hour, if that's okay with y'all. Okay, what have I ignored? What haven't I used yet?
Have
So
you
here's-
used 10 kilometers?
I've used that. 10 kilometers was a 10,000. That's in there. Okay, imagine what we've got so far. This is a circle. Is this butterfly just moving along a circle, going like that, and that's all? If you're watching the car go? And the answer is no. No, the car's moving. It's flying down the road. Does that make sense? So I need to add in the motion, the movement of the car, or how the center of the tire is changing. Is that clear? So let's do the easy one first. The easy is y, because the center is not changing. Do you agree? Where's the center of the tire in terms of y variable? It's pretty easy. Yeah, it's 1. So we have a 2 meter, we have a, sorry, it's not 2, it's 1, it's 2. It's 2 meter radius, so the center's up 2 from the bottom. So we need to go 2 plus. Any questions? And the x coordinate also is moving, right? The car is moving, but that one is more sophisticated, because the x is actually, the center of the car is actually moving. It doesn't just stay at the same spot. So how does it move? And the idea is it's going 10 kilometers per hour. So after 1 hour, it'll have moved 10 kilometers, which is 10,000 meters. So what we get is 10,000 t plus 2 cosine of etc. And there's our equations. Any questions on this idea? Okay, I got some more to go. I might go a few minutes over. I usually do that. Sorry about that, but not too long over. Okay. What if we have x of t equals 3t minus 1, and y of t is t squared minus 2t minus 5? 2t plus 2t minus 5. I want to write y as a function of x. I want to go backwards now. The hint is it's pretty easy in this case, because all I do is solve for t and whatever's easiest. And the first one's easiest. So I can write that I can add 1 and divide by 3. And I can say t equals x plus 1 over 3. Any questions on that basic algebra? Then what I could do is I could take my y equation and just substitute. And I could say y of x equals, well, everywhere I see a t, I can write t plus x plus 1 over 3. So I had a t squared. I don't want a t squared. I want an x plus 1 over 3 squared. I had a 2t. I don't want a 2t. I want a 2x plus 1 over 3. And there we go, done. It's especially easier typing because I can copy and paste it in. Have I lost anyone on that? Okay, this could be brutal, by the way, had like both of these be 5th degree polynomials. Good luck solving. Okay, or even this one. X of t equals cosine 2t, y of t equals sine t. If I don't want to use arc sine or arc cosine, can I still do this? And the answer is yes, but you got to remember your trig identities. What's cosine of 2t? Who remembers? If you don't, we'll do this just for fun. Let's see. It always gets it. Google's smart. There's the graph. Here's your identity. Let's go for purple math. Sound good? So if you don't remember, you can always find it somewhere in here eventually. There it is. So cosine 2x is 1 minus 2 sine squared of x. So that's all we have to do. 1 minus 2 sine squared of x. Or 1 minus 2 sine squared, not of x anymore, of t. But y is sine of t. So where I see a sine squared of t, I can write that as y squared. So I could say that x is equal to 1 minus 2 sine squared of t, which is just y squared. And I'm done. So notice that you may not have guessed that if you have x equal cosine 2t and y equals sine of t, that's a parabola on its sine. Any questions on what I just did? Okay, and my last thing, this is one of my favorite kind of applications, is we have one person who's walking along the path, y equals 1 minus x. And another person is walking along the path, y equals x. Well, they meet each other. What do you think? Well, let's take a look just for fun. So 1 minus x and x. Hopefully you didn't need Desmos to graph this, but you can. Did they meet? What do you think? Think we all say hi, you know?
It
Hey,
looks like it.
nice bumping into you. Are they going to say nice bumping into you or
But
not?
wait, what if they leave at like, you haven't told us when they leave in time or how fast they're walking.
Here it is.
If-
Actually, right. And that's the problem. Okay, is we don't know. So the reason I gave you this is because you can't say yes. They may not meet each other. They might meet each other. So here's a new way of saying it. What if one person is walking along the path x of t equals 1 minus 2t, y of t equals 2t, and another person is walking along the path x of t equals t plus 1, y of t equals t plus 1. Okay, notice that the first one is y equals 1 minus x. And the second is y equals x. Can you see that? Notice the second one, t plus 1 is both x and y, so y equals x. Now we can ask, well, they meet each other. Now we can actually define the question. Otherwise, you can't even answer the question. Well, if they meet each other, what does that mean? That means there's a time t at which you're going to have the same x and y coordinates. Any questions on that? So I'm going to use the y. So I can say that it's going to be a time t at which 2t is the same as t plus 1. Okay. And then just subtract t from both sides, you get t equals 1. Any questions on that? But at t equals 1, what are the x values? Well, the first x of t is equal to 1 minus 2 times 1, which is negative 1. And x of t for the second x of t, the other person, is at 1 plus 1. Which is 2. Do they meet each other? Do they get to say hi? Let's say t is in days, just for fun. No, because it's going to be like 3 days apart from when those things cross. Do you see that? So parametric equations tell you a lot more than rectangular equations and regular old equations. Parametric equations don't just say, do the curves intersect, which is true, they do intersect. It also tells you, do they meet at the same time? Any questions on that idea? Okay, so I'm a bit over time, so I'm going to stop my share. And hopefully I didn't blow you away and you have no idea what to do. And now you're like terrified of the class. Because today wasn't supposed to be a hard day, but a lot of little material. But I'm going to stop the recording.